Hello everyone, welcome to our channel. In today's video, we are diving into Interview Ready, Learn DBMS Fundamentals. Your quick guide to learn DBMS concepts and cracking interview questions with confidence. Let's get started. What is data redundancy in a database and how it can be reduced? Data redundancy refers to the unnecessary repetition or duplication of data within a database. This often occurs when the same piece of data is stored in multiple places. Data redundancy can be reduced in following ways: normalization, breaking data into smaller, related tables to eliminate repetition and improve consistency. Foreign keys, linking tables using references instead of duplicating data, ensuring relational integrity. Unique constraints, preventing duplicate records by enforcing uniqueness on key columns. Deduplication scripts, running queries or tools to identify and remove duplicate data from the database. What is a candidate key in DBMS? A candidate key is a column or a set of columns in a table that can uniquely identify each row. Each table can have multiple candidate keys, but only one is chosen as the primary key. For example, in a student's table we have 3 columns: roll number, email and name. So in this table both roll number and email can uniquely identify a student. It means both email and roll number are candidate keys. If we choose roll number as the primary key, email remains an alternate key. What is the difference between a superkey and a candidate key? Superkey. A superkey is any combination of one or more attributes that can uniquely identify a record in a table. It may contain extra attributes that are not necessary for uniqueness. There can be many superkeys in a table. It is not minimal, meaning some attributes might be unnecessary. Example, in a student table, student ID or student ID and name or student ID and email can be superkeys if student ID is unique. Where a candidate key is a minimal superkey, it asks a superkey with no extra or redundant attributes. It is the smallest possible combination of attributes that can uniquely identify a record. There can also be multiple candidate keys in a table. One of the candidate keys is chosen as the primary key. Example, if student ID alone is sufficient to uniquely identify a student, then student ID is a candidate key, but student ID and name is not. Summary: all candidate keys are superkeys, but not all superkeys are candidate keys. Candidate keys are the most efficient superkeys for identifying records. What are the different types of constraints in DBMS? Here's a list of common constraints in DBMS along with their definitions. Primary key ensures each row in a table has a unique and non-null identifier. Foreign key maintains referential integrity by linking one table's column to another table's primary key. Unique ensures all values in a column are distinct, allows nulls unless restricted. Not null prevents null values from being inserted into a column. Check restricts the values in a column based on a specified condition. Default assigns a default value to a column when no value is provided. Composite key, a combination of 2 or more columns that uniquely identifies a row. Auto increment, in some DBMS, automatically generates a unique number for new rows, e.g., MySQL. What is the importance of the commit and rollback operations? Commit operation commits all the changes made in the current transaction. Makes changes permanent in the database. Releases any locks held during the transaction. Ensures durability. The D in ACID. Changes become visible to other users. Used when a transaction completes successfully. Rollback operation undoes all changes made in the current transaction. Restores the database to its previous consistent state. Used when a failure or error occurs during a transaction. Ensures atomicity. The A in ACID. Either all changes are applied or none. Helps prevent corrupted or partial data. Can be used to handle user-triggered cancellations or system errors. What is an entity relationship diagram, ERD? An ERD is a simple visual diagram that helps us understand how different types of data are organized and connected in a database. You can think of it as a map of your database, like a blueprint before you build a house. It shows 3 main things: entities, these are things like student or course. Attributes, these are the details about the entities, like a student's name or ID. And relationships, which show how entities are connected. For example, a student enrolls in a course. Now, why is an ERD important? Well, it helps you plan and design your database properly before you build it. It makes it easier to understand the data structure. And it's a great tool to discuss requirements with your team or clients. Let's take a quick example. Imagine a school database. You have 2 entities, student and course. A student has attributes like name and ID. A course has attributes like title and course ID. And the relationship? A student enrolls in a course. What are the differences between an ER diagram and a relational schema? Let's begin with the ER diagram, or entity relationship diagram. An ER diagram is a conceptual model. That means it's used to show the big picture of your data, what kinds of data you have, and how they are related to each other. It's mostly used in the early stages of database design, to help you understand the structure before anything is built. It's a graphical tool, where rectangles represent entities like student or teacher, diamonds represent relationships like enrolls in, or teaches, and ovals show attributes like name or id. The ER diagram gives you an abstract view. It doesn't tell you how the data will be stored in tables, just what kind of data exists and how it's linked. It includes elements like entities, relationships, attributes, cardinality, how many, and participation rules. It's mainly used by database designers, analysts, and even non-technical stakeholders to plan the database. Now, let's talk about the relational schema. A relational schema is a logical model. This means it focuses on the technical details, how data will actually be stored in tables. It's used when the database is ready to be implemented. You already know what data you need, now you are figuring out how to store it. Unlike ER diagrams, the relational schema is written in text or formal notation. It includes table names, column names, data types, primary keys, and foreign keys. It gives a concrete view, showing exactly how the abstract ER diagram is converted into real tables. It includes things like tables, attributes, keys, indexes, and constraints. And it's mainly used by developers, database administrators, DBAs, and engineers while building or managing the database. Summary. Think of it this way. The ER diagram is like a blueprint. It shows what data is needed and how it relates. The relational schema is the construction plan. It shows how to store that data using tables, columns, and keys. So, ER diagrams focus on what data we need, while relational schemas focus on how we store and access it. What is the difference between a clustered and non-clustered index? First, what is an index? Think of an index like a shortcut. It helps the database find data faster, just like an index at the back of a book helps you find a topic quickly. Now, let's understand the two types. A clustered index is when the actual data in the table is stored in a sorted order, based on that index. Imagine a file cabinet where all files are arranged by employee ID. That's what a clustered index does. You can have only one clustered index in a table, because the data can only be sorted one way. It's great for range queries, like finding all employees between two ID numbers. Example, if there's a clustered index on employee ID, then all the rows in the table are stored in that order. A non-clustered index is different. Here, the index is stored separately from the data. It's like the index at the back of a book. It tells you where to go find the actual information. The data itself is not sorted by the index. You can have many non-clustered indexes in one table. It's best for quick searches, like finding one specific email address. Example, a non-clustered index on email helps you search emails quickly, even if the data is stored in order of employee ID. In simple terms, a clustered index is like arranging files physically in order. The data is sorted. A non-clustered index is like a lookup guide. It points to where the data is. Both are used to speed up queries, and knowing when to use which can really improve performance. What is a materialized view in DBMS? A materialized view is a pre-computed and stored result of a query in a database. Now, that might sound technical, so let's break it down. Book in simple words, imagine you have a complex SQL query that takes a long time to run. Maybe it's calculating total sales or joining multiple large tables. Now instead of running that heavy query again and again, what if you could just save its result, like a snapshot, and reuse it? That's exactly what a materialized view does. Unlike a regular view, which runs the query every time you use it, a materialized view stores the result physically, like a table. This makes it much faster to access, especially when the same data is used frequently. Key features. Let's go over a few key things that make materialized views special. It's stored on disk, so it doesn't run the query each time. The data is already saved. It helps improve performance, especially for things like reporting, analytics, or expensive joins. It can be refreshed, which means you can update it when the underlying data changes. You can refresh it on demand, whenever you choose. Or on commit, meaning it updates automatically when changes are made to the base tables. Light bulb example, say you want to see the total quantity sold for each product. Instead of running a sum query on the sales table every time, you can create a materialized view that already stores the total, and just read from it, much faster. Checkmark. When should you use a materialized view? When your queries are slow and complex. when the data doesn't need to be updated in real time, and especially when you're building dashboards, reports, or using data warehousing. So, to sum it up, a materialized view is like a cached result of a query. What is a database cursor? How is it used? A cursor is basically a pointer. It lets you go through rows in a result set one at a time. Thinking phase in simple words, when you run a SQL query, you usually get multiple rows back, right? But what if you want to process each row one by one? That's where a cursor comes in. It helps you handle rows individually, especially when you're writing logic in stored procedures or scripts. Using a cursor generally involves 4 simple steps. Declare the cursor. This is where you define the select query that fetches the data. Open the cursor. This runs the query and prepares the data. Fetch rows. You use a loop to go through each row and do some processing. Close the cursor. This step cleans up and frees memory. Think of it like opening a book, reading it line by line, and then closing it when you're done. When should you use a cursor? When you really need row by row processing. When your logic is too complex for a regular SQL query. Often used in stored procedures, triggers, or back-end processing scripts. One word of caution, cursors are usually slower than regular SQL operations. So, use them only when necessary. If you can solve the problem using standard SQL, that's usually the better choice. So that's it. A cursor is like a tool that helps you walk through your data, one step at a time, perfect for when you need precision and control in your SQL code. Thanks for watching. I hope you found the video helpful. If you liked it, don't forget to give it a thumbs up and subscribe to the channel for more interview-ready content.